All right, today we're going to talk about percent composition by mass and empirical formulas. The first thing that we want to take a look at is that the law of definite proportions tells us any sample of a pure compound will always have the same ratio of constituent elements, or the elements that make it up. For example, sulfur trioxide will always have 1 mole of sulfur for every 3 moles of oxygen. And so that allows us to calculate how much of a certain atom is in the compound. The steps for calculating percent composition start with calculating the formula mass of the compound, then you're going to calculate the formula mass of each element and divide that by the total formula mass. Which is what we mean with part divided by whole. So the part would be the atom that you're looking at, and then the whole would be the total formula mass. And then the last step is just to multiply by 100 to turn it into a percent. All right, so with phosphoric acid, we've got the hydrogen. So 1.008 times 3 plus 30.097 for the phosphorus plus 15.999 times 4 for the oxygen, and that equals 97.994 grams per mole. Now, we want to know what percent of that mass is oxygen, what percent is phosphorus, and what percent is hydrogen. So for the part that is oxygen, that's 15.999 times 4 divided by the total formula mass, which is 97.994, and then times 100 gives us 65.306%. So that's the percent composition of oxygen in the phosphoric acid. Then if we do the percent composition of phosphorus, the part that phosphorus is 30.097 divided by the total formula mass, which is 97.994, and then times 100 is 31.608%. So with this, we know 2 out of the 3 percentages of the atoms that make up phosphoric acid. So we can do the same calculations that we did for these two to calculate the percent composition of hydrogen. So we'll do 1.008 times 3 divided by the total formula mass, 97.994 times 100, and that equals 3.086%. If you didn't want to do that calculation, you could just add these two percentages together. So 31 plus 65.306, and then 100 minus whatever that number is should equal this number. So you can just combine these two percentages together, subtract from the total of 100%, and you still get this same answer. So whichever way you want to solve that, you can. Our next topic is the empirical formula. So far, we've covered molecular formula that tells you how many atoms of each element are in a compound. So, for example, we know that there's 1 sulfur in sulfur trioxide and there's 3 oxygens in sulfur trioxide. The empirical formula is the simplest formula ratio. It tells you the most reduced ratio of an element in a compound. So we'll highlight that part. If a compound's molecular formula can't be reduced anymore, then it will be the same as the empirical formula. So if we're going from the percent composition to the empirical formula, we have a handy little jingle, I guess, that we say. We say percent to grams, grams to moles, divide by small, and then multiply till whole. So it just reminds us the steps to do to go from percent composition to finding out what the empirical formula is. So let's start with example 1. A compound of iron and oxygen is analyzed and found to contain 69.94% iron and 30.06% oxygen. And we want to find the empirical formula. So we're going to start with the iron. It's 69.94%, and we're going to change that percent sign to grams. So instead of percent, that will be grams. That's our first, percent to grams. And then we're going to convert grams into moles. So we have 69.94 grams of iron, and then 1 mole of iron goes over the formula mass of iron, which is 55.845 grams. So that is 1.252 moles of iron. Then let's go back to the oxygen. So oxygen, it told us is 30.06%. We're going to change that percent to a gram sign. So 30.06 grams of oxygen times 1 mole of oxygen over 15.999 is equal to 1.879 moles of oxygen. Okay, now step 3 said divide by the smallest number. So we compare our two numbers of moles. The smaller of these two is 1.252. So when we divide by 1.252, that equals 1 for iron, and it equals about 1.5 for oxygen. So then our fourth step says multiply till whole. So this is already a whole number, but 1.5 is not. So if we're going to multiply that to get a whole number, we need to multiply that by 2. So that equals 3. If we multiply the oxygen by 2, we've got to multiply the iron by 2 as well. So times 2 equals 2. These two numbers are going to be our subscripts in the formula. So our final answer, maybe I shouldn't have moved that, but is going to be Fe2O3. That is our empirical formula. All right, so let's try another one. The next example says a compound is found to contain 31.42% sulfur, 31.35% oxygen, and 37.23% fluorine by weight. What's the empirical formula? So let's just break it down. We'll start with sulfur. Percent to grams. So 31.42% has been changed into grams. And then we've got 1 mole of sulfur over 32.066 grams. This is just off of the periodic table. And so when we divide that, we get 0.9799 moles of sulfur. Then we can go to oxygen. It's 31.35% gets changed to grams. And then 1 mole of oxygen is equal to 15.999 grams of oxygen. So then when we divide those, we get 1.959 moles of oxygen. And then last but not least with fluorine, 37.23% gets changed to grams. And then on the periodic table, we know that 1 mole of fluorine is equal to 18.998 grams. And so when we divide that, we get 1.960 moles. So we've gone percent to grams, we've gone grams to moles, now we divide by small. So the smallest of these three numbers is the top one. So we're gonna divide by 0.9799. That equals 1. That equals 2. And then this is pretty much the same, so it will equal, 2 as well. All of these are whole numbers, so we don't have to multiply any. We didn't have any that kind of rounded off to a decimal. And so that means our empirical formula is going to be SO2F2. And there you have it. All right, so that's empirical formulas.